the lesson, I will send you this video. Okay, the question was, we have 5 numbers. These numbers are random numbers, something like this. And we should arrange it maybe in increasing or decreasing order. I think it doesn't matter for you. Let's consider in the order of increase. So the first should be 1, the second 2, the next 4, next 10, and 65. There are a lot of methods how to solve this problem. These methods are called sorting algorithms. And if you type again, I always show you this solution, how you can find any answer for your questions. You type the request in Google search, sorting array, something like this. And okay, it's better sorting algorithms. And I think the first, not the first, but the second link, it will be the link to the Wikipedia page, and you can find here a lot of algorithms. Of course, some of these algorithms are rather complex, but we start from the, now we consider the simplest, maybe the simplest one, so-called bubble sort. You see, there are a lot of algorithms. Let me find here bubble sort. As you see here, of course, I don't remember it, but as you see here, this algorithm was suggested in 1956. And the algorithm is extremely simple. The illustration is here. We consider 2 numbers, and if these numbers are in good order, in the order of increasing, we do nothing. But if these numbers are in the wrong order, we change these numbers. And after one step of this algorithm, the largest element will be in the last position. And after that, we repeat the algorithm with the rest of the array. Let me, okay, you can find these in Wikipedia, but let me show you how it works in Visual Studio in the form of, I write it here in a comment. So this is the initial array. We take 2 neighbors, take 2 numbers and compare it. We decide to sort this array by increasing. 4 and 2 is the correct order of the elements. No, because 2 is less than 4, and we should change it. 2 and 4. The rest of the array is the same. The rest of the array is the same. Wait a second, what happens? The rest of the array is the same, and after that we consider next two numbers, 4 and 65. Are these numbers in the correct order? Yes. Yes, because 4 is less than, and we do nothing. Next, 65 and 1. Wrong. We should change it. 165. After that, 65 and 10. Again, wrong. We should change. We should put 10 here. And when we look to all of the numbers, you can find that the largest number will be in the last position. And after that, we should repeat this algorithm with the rest of the array. And when we repeat it, the second largest element will be in the second position. These numbers, good. These numbers, no. You should change it. 1, 4, 4 and 10. Okay. Okay. And two elements will be in the correct positions. And so on. Again, the main idea of this algorithm is to compare two neighbor numbers and change it. If the number is yes, if these numbers are in their own order, and repeat this algorithm, repeat this change many times, and after this, the array will be sorted by increasing. Let's implement this algorithm. Let me declare array of size element before const size equals to 5, for example. Let me assign here. I take these numbers. I take these numbers from my example. I take these numbers. I assign their numbers, or const int, of course, const int size. Well, this is the array. This is the numbers. I start from the, not from the beginning, but from the end of the program. In the end of the program, what should I do? I should output the array to the screen. Let me write the final for that outputs the array to the screen. I smaller than size I plus plus, and C out array with index I. Space and end of line. This program now does nothing. It just outputs the array to the screen. Let's look again to this program. Let me run it, and we should see on the screen this array unsorted. Well, after that, let's implement the algorithm. We start from the simplest version. We start from the simplest version of this method. Let me use another counter, j, for int j equals to 0, j smaller than size, j plus plus. What should I do? I should compare two numbers. These numbers are neighbor numbers. So the indexes of these numbers are j and j plus 1.
This one.
If the current number is greater than array of j plus 1, in this case, we should replace this number. If the number with index j is greater, in this case, we should change it. How to change? I should introduce a new variable, some variable tmp, array I, then array I equals to, sorry, why I? J, of course. J, array j equals to array j plus 1 and array j plus 1 equals to tmp. Well, could you guess what will we see on the screen? What will we see on the screen if this loop works one time? What we see on what will be the final state of the array? Two, 4. No. We look at if this part of the loop works only one, but if this loop will be completed, what will we see on the screen? If this loop will be completed, in this case, we will see the largest number.
65 will be in the end.
Yes, in the end of the table, right. Well, and by the way, this loop contains one mistake. One mistake. Maybe somebody could guess what mistake. Please look to this loop. Oh, sorry. Please look to this loop. Could you guess where is the mistake?
G.
No. You write only at that the mistake is here. But what mistake? Mistake is here, right? But what? No, no. Less than or equal? No. Let's remember, let's recall. If the number of elements in the array is size, what are the indexes of these elements? What is the first index? I ask all of the students, please write your answers in chat. Tell your answers by your microphone. What is the first index of the element in the array? The first index. The first index is 0. Any array we take, the first element has the index 0. What about the last element? What is the index of the last element? No, not the number, not the value, but the index. The 4, right? In this case, 4. But in general case, if the number of elements is size, what is the index of the last?
Size minus 1.
Size minus 1. Right. Size minus 1. And if I write here the condition j less than size, the last value of j will be size minus 1. But if j equals to size minus 1, j plus 1 will be size. And the index will be outside of the range. This condition responds to the index that is out of the range. And to fix this mistake, I should write here size minus 1. Not less than or equals, but size minus 1. If I write here size minus 1, the last index of the last number of j will be size minus 2. And if j equals size minus 2, j plus 1 will be size minus 1. That is inside. Well, let's run this algorithm and let's look what we will see on the screen in the end. We will see the last number in the correct position, but all other numbers are in wrong positions. And we should repeat this. We should repeat this algorithm several times. We should repeat it. And the main and the simple case how to repeat this algorithm is to write another loop. So this algorithm, this loop, it must be the inner part of another loop. I should write one more loop for I equals to 0, I smaller than size 5 plus plus, and repeat this algorithm size times. As far as I write here one more loop, this internal part will be repeated several times. And we will see on the screen the correct result. 1, 2, 4, 10, 65. It doesn't matter what is the size of the array. Let's consider 7. Let's write here maybe 5, 8, something like this. We will see the final result in right order. This is the most simple case, but I can write and I can suggest another version of this algorithm. let's look to these initial arrays. When we implement one step of this algorithm, the largest number will be on the last position. And the next search, the next step of the algorithm, we can work only with this part of the initial array, because the last number is already, the largest number is already in current position. We can skip it, and we should work only with the first 4 numbers. On the next step, 10 will be in correct position, and we can work only with 3 numbers. So, step after step, the size of the array, the size of the part of the array that we work, the size of the part of the array becomes smaller, smaller, and smaller. What happens after the next step? We consider the 4 will be on the current position, and we should consider only these 2 numbers. So when the algorithm works, the part of the array will be smaller, 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 and smaller, step after step. How we can do it? We can do it very simple. We can do it very simple. As far as we have counter I here, I can write here not only size -1, but size -1 minus I. In this case, the part of the array will be smaller when the I becomes larger. The initial value of I is 0, and we have size -1. Next value of I will be 1, and we will have here size -2, and so on. The final result will be the same. We will see the sorted array, but the speed of this algorithm, the number of operations, will be significantly reduced. Well, this is maybe the most simple and the most oldest algorithm of sorting. As you see, as it's written in Wikipedia, this algorithm was suggested more than 70 years ago. You can read, there are a lot of examples here, step-by-step example, and so on. It's very good. You can find here also pseudocode, and I think maybe it's even no, C++ code is not here, but you can find pseudocode, the algorithm that is written in a form that is close to the programming language. Well, some questions about sorting. Any questions? No. Maybe you have other questions. It's it's very good that you have questions. It means that you try to understand something, you have a problem, and I explain it for you. Maybe next time, one of the lessons, we consider more complex algorithms for sorting, because the bubble sort is very slow algorithm. It sorts the array, but it works very slow. Of course, when we sort 6 or 7 numbers, it doesn't matter what algorithm to use. But if we will sort, for example, 1,000, 10,000 numbers, it will be a difference what algorithm to use. Well, if you don't have any questions now about algorithms, let me consider one rather short but important thing related with arrays again, because the arrays is one of their most important parts. Let's discuss about so-called two-dimensional arrays. When we work with arrays, usual arrays, we consider it like a sequence of numbers. Sequence of numbers like this, or like this. Just some sequence of numbers. But there are a lot of problems. A lot of problems in mathematics, a lot of problems in programming, where we should consider the numbers not in the form of a sequence, but in the form of a table, like it's like you see here on presentation. When we consider the sequence, each element of this sequence has only one index. For example, A0, A1, A2. But when we consider the table, in this case, each element of this table has two indexes. When we consider the table, each element of the table has two indexes. The row number, and column numbers. And usually it's denoted as I and J, and these elements has two indexes. I, it's the row number, and J is the column number. We can select, for example, first row, first column, and this number has indexes 1, 1. Yes. And so on. But again, as in this in the previous example, there is a in mathematics and in real life, usually we use the numbers that starts from 1. Yes, and this first element usually we denote as 1, 1. But in programming, all the enumerations starts from 0. And the first element will have two indexes, 0 and 0. And we can work with such object, the table of the numbers. And in programming, this table is called two-dimensional array. Yes, matrix. Yes, first dimension. Rows second dimension columns. And the syntax of the language allows us to create two-dimensional arrays. The general form is written here. Let me write here just ID instead of mass. This declarative statement we can use to declare two-dimensional array. ID, it's just the identifier. You can use any identifier that you want. N is the number of rows. K is the number of columns. And the type is the data type of the elements from this two-dimensional array. When we consider static arrays, N and K must be constants. We can create two-dimensional array of the fixed number of rows and fixed number of columns. Well, let's consider it in Visual Studio. I just write it here. I comment this and part of the program and write here. Int m 2 3. That's all. I declare two-dimensional array with 2 rows and 3 columns. Of course, it's better to write constants. As in previous case, const int it's better to row n, row number equals 2, and column number equals to 3, something like this. Row number, column number. How to work with two-dimensional array? To work with two-dimensional array, we should write 2 nested loops, one inside the another loop. The first loop will work with rows, the second loop with columns. For I starts from 0, I smaller than row number, I++, and the second loop for in j starts from 0, j smaller than column number, j++, and here inside the inner loop, I can get the access to the elements of the array using the indexes I and j. For example, let's assign here I plus j. This is a typical construction that allows to work with a two-dimensional array. Let's output the values of the array to the screen. What should I do? I should copy this loop, and instead of assignment operation, write here the output operation. Out. By the way, what will we see on the screen if not zeros, we see all the numbers, but without spaces between these numbers. I can run this program. This program is correct, but we will see these numbers without spaces. Okay. Let insert space between numbers. What will we see on the screen? We will see these numbers, but we will see it not in the form of the table, but in the form of one line. Let's think where we should insert the not slash t, but the slash n or end of line, the break, the line break, where we should insert it. Loop, the first loop will correspond to the first loop corresponds to the rows. The second loop corresponds to the columns. So when the index j moves from 0 up to column number, it means that we process one row. We process all of the elements of the one row. The first loop fix the row number I, and the second loop, it moves the column number from 0 up to the last. So we should insert the break of the line after the second loop. And now, if I run this program, I will see on the screen the table. First row, the first row, the second row. Let's increase the number of rows, not 3 and 4, for example, 6 and 8. We will see the table. 6 rows, 8 columns. And I fill this table with the sum of the indexes. The first index is 0 plus 0, and the last index is 5 plus 7. 5 plus 7 is 12. I can write here not plus, but multiplication. In this case, I will see another table with another numbers. Well, let me come back to the presentation. Two-dimensional arrays can be considered as a array of the rows. I can consider two-dimensional array as a one-dimensional array that consists of the rows. the first row, first element. Second row, second row. Third row, third row. Array of the rows. And on this, based on this idea, I can initialize two-dimensional array on the following way. I can write figure bracket. After that, one more figure bracket, and write here all of the elements of the first row. Then, comma, and all of the elements of the second row, and so on. Let me come back to this example with 2 and 3. This part, the assignment I comment, and let's write initialization list. Well, what should I write in figure brackets? Our table consists of 2 rows, and each row consists of 3 columns. So the first row, 3 columns. For example, 3, 4, 5. This is the first row, comma, and the second row. The second row, for example, 3, 2, and 1. And the end of the table. So this is the first row, this is the second row. And our array will be initialized with these elements. But usually we can initialize only the arrays of rather small size. If the number of rows is greater than 10, the number of columns is greater than 10, it's very hard to write in the program all of the numbers here. Only if the number of rows and number of columns are significantly small. Well, this is the example, again, how we can initialize the array of 3 rows and 3 columns. Like here, like the first row, the second row, third row, and so on. Well, the rules of initialization is the same if the number of elements in the initialization list is less than the size of the array. In this case, the missing elements are filled with zeros. Let's check it. Suppose that I 5 row and 5 columns, but I initialize only this small part of this table. What will we see on the screen? We will see this small part initialized with these numbers, and the other numbers will be zeros. If I skip initialization, for example, suppose that I did in this case, this array is considered to be undefined. And I will see some numbers without initial values. the elements of two-dimensional array are placed in the memory. So now just a few words about the how two-dimensional array are placed in the computer memory. In the memory, this two-dimensional array is placed not in the form of the table, but it's written as one very, very large one-dimensional array. It's written in the following form. Row number 1 and row number 2 is written not below, but after. This is row number 3. Then row number 3, and so on. The elements of the rows is written here. And so on and so on. So in computer memory, actually, the two-dimensional array is written not like this, like we write it on the paper, but it's written as one very large one-dimensional array, row by row. The example is written here on this slide. First element corresponds to the first row. Second element corresponds to the second row. Next element to the third row, and so on. In computer memory, two-dimensional array is written row by row. Well, I don't want to consider dynamic two-dimensional array. I think it's enough that we consider static two-dimensional arrays. There are a lot of algorithms with two-dimensional arrays that can be implemented, but I think we consider it next lesson, next time. Well, next lesson, I will plan to consider functions. We discuss how to write functions in C++. Now I stop sharing and I stop recording.